Good morning, everyone, and thank you for being here today. I'm pleased to welcome you to this presentation. Today, we'll be discussing a comprehensive approach to batch reconciliation in API manufacturing. My name is Dr. S.K. Singh, and I hold a PhD in this field. Over the course of this session, we'll explore key strategies and best practices to improve accuracy and efficiency in batch reconciliation processes. I look forward to sharing insights that can help optimize your operations. Let's get started. Let's talk about batch reconciliation. Essentially, it's the complete accounting of materials at each stage of the process. This step is critical in API manufacturing because of the complexity involved in multi-step synthesis. You have to carefully track solvents, reagents, and intermediates to ensure everything is documented accurately. Why is this so important? Well, it provides traceability, so we can follow each material through the entire process. It also helps us control yields, making sure we get the expected amount of product at the end. And of course, it maintains process integrity, ensuring everything is consistent and compliant with quality standards. This practice isn't just good practice, it's a core GMP requirement. It underpins the entire quality and safety framework of pharmaceutical manufacturing, especially when dealing with complex APIs. So, in our overall theme, batch reconciliation is a fundamental tool that supports quality, compliance, and ultimately, patient safety. Let's take a closer look at the stages of reconciliation in the API manufacturing process. We start with raw material dispensing, which is where we carefully measure and prepare our starting materials. Next comes the reaction stage, or synthesis, where the core chemical transformation happens to form the API. After that, we move into the workup and isolation phase, where we separate our product from the reaction mixture. This is followed by purification, typically through crystallization or filtration, to ensure the product's quality. Then, we dry and mill the API to get it into the right physical form for packaging. Finally, the last step is API packing, where the product is prepared for distribution. Reconciliation is essential at each of these critical steps to ensure accuracy and quality control. The scope of this process covers everything from raw materials, including starting materials, intermediates and solvents, to reagents and ultimately, the final API. It's important to note that reconciliation isn't just about one step. It's integrated throughout the entire process, from synthesis through purification, drying, and finally, packing. This comprehensive approach helps us maintain transparency, consistency, and quality in the production of our active pharmaceutical ingredients. Now, let's take a closer look at the material balance equation. This is the fundamental principle that helps us understand how materials move through a process. Essentially, it states that what we issue as materials equals what we use, recover, waste, sample, lose, or return. It's important to remember that this equation accounts for everything involved in the process. For example, solvent recovery is a key aspect. Any solvent we recover reduces waste and impacts the overall material balance. Similarly, the mother liquor, which remains after crystallization or filtration, is part of the equation. Byproducts are also important. They're substances produced alongside the main product, and tracking them helps us understand process efficiency. Moving on to yield calculation, which is a crucial measure of process success. The formula is straightforward. Yield percentage equals the actual yield divided by the theoretical yield, multiplied by 100. It's vital to have predefined expected yield ranges so we can benchmark our process. If the actual yield deviates from these ranges, it's a signal that we need to investigate potential issues. This approach aligns with good manufacturing practices and helps ensure quality and consistency in our production. Overall, understanding these concepts is key to optimizing our processes and maintaining compliance with regulatory standards. In this slide, we're looking at the crystallization step. So we start with an input of 85 kilograms of crude product. The goal here is to recover the pure crystals, which in this case amount to 75 kilograms. Along with that, we have the mother liquor, which weighs 8 kilograms and a small loss of 2 kilograms. It's important to verify that these numbers add up correctly. So if you do 75 plus 8 plus 2, you get 85 kilograms, confirming our mass balance is accurate. Now, a critical point here is that the mother liquor, which contains residual product, must be carefully tracked and documented. This is essential for quality control and process validation. Proper documentation ensures we understand how much material remains in the mother liquor, which can be recovered or disposed of responsibly. This whole process highlights the importance of meticulous record-keeping and accuracy in each step, making sure our process is both efficient and compliant with standards. Now, let's take a look at the final API yield. The theoretical batch size was 70 kilograms, but the actual final API we obtained was 68 kilograms. To calculate the yield, we divide the actual yield by the theoretical batch size and multiply by 100. So, 68 divided by 70 equals approximately 0.971, and multiplying by 100 gives us a yield of 97.1%. It's important to note that the final yield should match our specified targets, ensuring our process is consistent and efficient. Next, let's examine solvent recovery. We issued 500 liters of solvent for this batch. After processing, we recovered 450 liters, which shows us how much solvent was successfully reclaimed. The evaporation loss, or the solvent that evaporated during processing, was 30 liters. Additionally, there was a residue of 20 liters that couldn't be recovered. When we add up the recovered solvent, evaporation loss, and residue, so 450 plus 30 plus 20, we reach a total of 500 liters, confirming that our solvent reconciliation checks out. This step is crucial because solvent reconciliation helps us track and control our material use accurately. Proper management of solvent recovery not only impacts cost efficiency, but also supports compliance with environmental and safety standards. As we've seen, maintaining detailed records and checking our calculations regularly ensures the integrity of our process. To wrap up, these examples highlight the importance of accurately calculating yield and carefully managing solvent recovery, which are both key to maintaining quality and optimizing our manufacturing process. Let's take a closer look at acceptable limits in our processes. Typically, based on validation data, reaction yields should fall within the range of 90 to 98%. This means that when the reaction is working as expected, most of our starting material is converting efficiently. For crystallization, an acceptable range is usually between 80 and 95%. This indicates how much of our product is successfully crystallized out of the solution, which is crucial for purity and yield. The overall yield, however, can vary depending on the specific process we're working with. It's important to remember that these ranges are not arbitrary. They're defined based on historical batch data and thorough process validation. By analyzing past batches and validating our process, we ensure these limits are realistic and serve as benchmarks for quality and consistency. This connection between data, validation, and acceptable limits helps us maintain high standards and continuous improvement in our manufacturing. Now, let's take a closer look at deviations and investigation. When we encounter triggers such as yields falling outside the established limits, missing materials, or unexpected gains, it's essential to act promptly. According to ICH Q7 guidelines, any deviation like this requires a thorough, documented investigation. We need to understand what caused the deviation and assess its impact on the overall quality of the product. Once we've identified the root cause, the next step is to implement appropriate actions. This typically involves conducting a root cause analysis, or RCA, to dig deep into the underlying issues. Following that, we put corrective and preventive actions, CAPA, into place. This structured approach helps us not only address the current deviation, but also prevent similar issues in the future, maintaining our commitment to quality and compliance throughout the manufacturing process. Now, let's take a closer look at the documentation requirements that are essential for maintaining quality and compliance. First, we have the Batch Production Record, or BPR. This document captures all the critical steps and parameters during production, ensuring we have a complete record of each batch. It's vital that these records include actual values observed during the process, such as temperatures, times, and measurements, to verify that everything was within specified limits. Next are the raw material logs. These logs track the receipt, testing, and usage of raw materials. Proper documentation here ensures traceability back to the supplier and confirms that materials meet quality standards before use. Speaking of traceability, every entry should be signed off by authorized personnel, providing accountability and a clear audit trail. Then we have yield calculation sheets. These are important for assessing the efficiency of our process, and again, they must include actual yield values. This not only helps in process optimization, but also in troubleshooting if yields fall below expectations. Solvent recovery logs are another key component. They document the recovery and reuse of solvents, which is critical for both safety and environmental compliance. Detailed logs ensure we can trace solvent usage and recovery rates accurately. Finally, deviation and corrective and preventive action, or CAPA reports, are essential for capturing any deviations from standard procedures. These reports should include detailed descriptions, root cause analyses, and the actions taken to prevent recurrence. Proper documentation here ensures continuous improvement and regulatory compliance. In summary, thorough documentation with actual values, signatures, and traceability isn't just about record keeping. It's about ensuring the integrity of our process, accountability, and compliance with industry standards. Let's take a closer look at some of the common challenges we face in multi-step synthesis processes. First, the complexity of these syntheses can really add layers of difficulty, making it harder to control every step precisely. Then, there's the issue of solvent losses, which might seem minor but can accumulate and impact the overall yield and purity. Tracking intermediates throughout the process is also crucial, as missing a step or losing track can lead to inconsistencies. Additionally, carryover residues from previous batches pose a significant challenge, especially when it comes to ensuring product purity and compliance. This is where ICH Q7 comes into play. It specifically highlights the risks associated with residue carryover between batches, emphasizing the importance of stringent cleaning and validation practices. Ultimately, understanding and managing these challenges is essential for maintaining quality and compliance throughout our manufacturing processes. So, to wrap up, let's talk about reconciliation as a critical aspect of good manufacturing practice, or GMP, in API production. Essentially, reconciliation is about ensuring that every step in the manufacturing process is tightly controlled and accountable. This means we need to maintain strict material accountability, making sure all raw materials are tracked and accounted for throughout production. It also involves safeguarding batch integrity, ensuring each batch is consistent, complete, and meets quality standards. And of course, regulatory compliance is fundamental, making sure our processes align with all the necessary guidelines and regulations. Now, the key to making this work effectively is having strong standard operating procedures, or SOPs, paired with real-time reconciliation. When these elements are in place, they form the backbone of a robust API quality system. This system not only helps us prevent errors and deviations, but also ensures the highest quality and safety for the final product. So, in the bigger picture, reconciliation is really about integrating controls and oversight seamlessly into our manufacturing process, which ultimately supports consistent quality and regulatory adherence. For further support, please don't hesitate to reach out to us. We're here to help you with any questions or additional assistance you might need. Thank you so much for your time and attention today. We truly appreciate your engagement and look forward to supporting you moving forward.